Class 12th Chemistry. Hello alkanes and hello arenes, and in this video we will discuss about elimination reactions, reaction with metals, Grignard reagents and Wurtz reaction. First come to elimination reactions. When a haloalkane with beta hydrogen atom. Okay, first of all understand what is the meaning of this beta hydrogen. Carbon on which halogen atom is directly attached is called alpha carbon, and the carbon atom adjacent to this carbon is called beta carbon. You can see this is the halogen attached with this carbon, this is alpha carbon, and adjacent to this carbon this is a beta carbon, and hydrogen atom attached to this carbon is known as beta hydrogen. Okay. When haloalkane with beta hydrogen atom is heated with alcoholic solution of potassium hydroxide. Again remember, alcoholic, not aqueous. Okay, alcoholic solution of potassium hydroxide, there is elimination of hydrogen atom from beta carbon and a halogen atom from the alpha carbon atom, and an alkene is formed. Okay, and it involves the elimination of beta hydrogen. That's why this is known as beta elimination. And in this case, one hydrogen and one halogen is removed. That's why this is known as dehydrohalogenation. Okay, dehydrohalogenation. You can see this is the one general reaction. This is alpha carbon to which halogen is attached. This is beta carbon, and that's why this is beta hydrogen. When this react with the base like OH minus ion, alcoholic potassium hydroxide, this hydrogen along with this X is removed and we will get this alkene. Okay. Saytzeff rule. In dehydrohalogenation reactions, if there is possibility of formation of more than one alkene, okay, if haloalkanes contain more than one beta hydrogen, then there is a possibility of formation of more than one alkene. Then alkene which has the greater number of alkyl groups attached to the doubly bonded carbon atoms is formed as the major product. For example, 2-bromopentane gives pent 2-ene as the major product. You can see the structure of this 2-bromopentane. Now this is halogen attached to this carbon, that's why this is alpha, and adjacent to this is beta, and this is also beta. Okay, if this hydrogen atom is removed along with this Br, then double bond will created here and we will get this pent 1-ene which is minor, only 19%. But when this hydrogen which is attached to this beta carbon, this one of the hydrogen atom from this carbon is removed, then we will get this one. Okay, CH3, CH2, CH, double bond CH, CH3. This is pent 2-ene and this is the major product, and this is 81%. Okay, now what is the meaning of this greater number of alkyl groups attached to doubly bonded carbon atoms? Just see this. These are the doubly bonded carbon atom, and these two carbon atoms only one alkyl group, this one is attached, while in this case these are the doubly bonded carbon atoms and they contain, this is one alkyl group and this is another alkyl group. That's why more number of alkyl groups attached to doubly bonded carbon atom in this pent 2-ene. That's why this is major product. Okay. Reaction with metals, organometallic compounds, and we will discuss about the Grignard reagents. The chemical compounds which contain at least one bond between a metallic element and a carbon atom belonging to an organic molecule are known as organometallic compounds. An important class of organometallic compounds discovered by Victor Grignard in 1900 is alkyl magnesium halide, that is RMgX, and these are referred as Grignard reagents. Okay, and these Grignard reagents in the short form you can also write GR. These reagents are obtained by the reaction of haloalkanes with magnesium metal in dry ether. Okay. Again, you can see this is the haloalkane CH3CH2Br magnesium in the presence of dry ether. Again, what is the meaning of this dry ether? That is ether which is free from any moisture content. We will get this one CH3CH2MgBr. This is ethyl magnesium bromide. This is Grignard reagent. Okay. Bonding in Grignard reagents. In Grignard reagent, the carbon magnesium bond is covalent but highly polar, with carbon pulling electrons from electropositive magnesium, and the magnesium halogen bond is essentially ionic. You can say this one is this magnesium halogen. This is essentially ionic, while this let me say it involves the carbon of alkyl group. The bond between this carbon and this magnesium, this is polar, because carbon is more electronegative than magnesium and it pulls this electron pair towards itself. That's why it acquired the partial negative charge. Okay. Reactions of Grignard reagents. Grignard reagents are highly reactive and react with any source of proton to give hydrocarbons. Even water, alcohols, amines are sufficiently acidic to convert them to corresponding hydrocarbons. You can say that is RMgX. When react with the water, then we will get RH and this MgOHX is obtained. This is hydrocarbon. Okay. It is therefore necessary to avoid even traces of moisture from a Grignard reagent. Okay, there should no single amount or even small amount of moisture should be present. That's why it is prepared in the presence of dry ether. We already discussed. And this reaction is used for converting halides to hydrocarbons. How? Okay, if you are given that this CH3Br, and how will you convert this into CH4? Okay. Then what will you do? First, this will react with the magnesium in the presence of dry ether. Okay. Then what we will get? This is methyl magnesium bromide. Okay. And when this methyl magnesium bromide is treated with the water, we will get CH4, methane. That is from methyl bromide we get methane. Okay. Wurtz reaction. Alkyl halides react with sodium in dry ether to give hydrocarbons containing double the number of carbon atoms present in the halide. This reaction is known as Wurtz reaction. You can say this is two molecules of alkyl halide. When react with the sodium in presence of dry ether, we will get higher alkane and NaX is formed. Okay, and this reaction is used to convert methane to ethane. How? Just see, this is CH4 and we have to convert this into C2H6. First of all, this is converting into, suppose this is react with the HCl. This will convert into CH3Cl. Okay, and when this react with the sodium in presence of dry ether, then this will, its two molecules will react and this will convert into this. Okay student, thank you.